This is the Suunto MB-6 military compass, and it looks different from most other compasses, but this one has one of the most amazing, cheap and simple ideas for a military compass that you just won't see anywhere else, and it works brilliantly. And I'm not sure why other military compasses, in fact even normal trekking compasses, why they don't have this feature. So we'll go through that in a while. Now, if you're watching, Commenga, Silver, Breithaupt, Pfizer and all you other military compass manufacturers, pay attention. Things don't need to be expensive to make a really big difference. Now, these compasses are still used by the Swiss military, and the design is basically the same as was issued to army officers during the Second World War. And today I want to go through how to use this strange looking compass in a box. But first, we'll go through all the various parts of the compass, just so you know what I'm referring to later on. Now, on the top of the box, you can see two luminous points. These are your sighting points. There's also a permanently attached lanyard with a small screwdriver looped through it. And to open the compass, you just slide out the drawer from the lanyard end. There's another luminous point. This is the index point, and it's a small arrow. As an example, if you rotate the bezel, you'll see this is a bearing of 70, and this would be a bearing of 260. So that's where you read the bearing from. The main thing you'll notice once you've opened the drawer is the bezel itself, which is black with white writing or white printing. And this makes it really easy to read, and the degrees are marked in 2-degree increments. Inside the dial you have the magnetic needle. Now, you can buy Suunto MB-6 globals, but this particular compass that I've got isn't a global. It's just got a normal needle that doesn't have a global needle. Also inside the dial is a small red pointer, and that's the inclinometer. To use the inclinometer, if you look on the back of the compass, you can see the circular angle marks there written onto another sort of white strip there. Hold the compass so that it's at the same angle as the slope, and then you read the slope angle there where the red pointer points to. I mean, if you're a geologist, you know, charting the strike in map view or the dip in cross section, I'm not sure this would be the ideal compass for you, but if you've got nothing else, this would work. Just a quick point here, whilst we're looking at the back plate, if you ever wanted to change the lanyard, all you need to do is carefully undo the 3 little screws there, and then that would give you access to the lanyard placement, so you'll be able to put a new lanyard on it. If we turn the compass back over again, we can see that inside the dial there are 2 luminous lines. These take the place of the orienting arrow on most other compasses. And when you tilt the compass forward like this, you'll see a mirror will drop down. And this is to stop parallax errors when you're taking a sighted bearing. In some countries, a sighted bearing is called shooting in azimuth. And I'll go through how the mirror works, you know, once we get onto using it. As I said, this is a military compass, and I'm not really sure if the printed information that's on the back of the mirror would be useful to any civilians who buy it as a trekking compass. But in the spirit of you know, a full instruction video, I'll go through what these numbers are. And don't forget that this is a military compass, so I'm not going to go into too many details, as I'm only really interested in civilian navigation. I do teach military folk, you know, to walk around the countryside, hopefully without getting too lost, but my videos are always about civilian navigation. So what this sticker does is it gives you a quick conversion for the most commonly used military ways of saying a certain angle. So that would be flat, that would be up. So that's 2 very basic angles, flat and up. Anyway, let's go through what these mean, these numbers. The first column gives you degrees, so that's where a circle is divided into 360, and as an example, 25 degrees. The second column gives you grads or gons or gradients or whatever you want to call them, and this is, in this case, the circle is divided into 400, with each right angle having 100 gradients. So as an example, our 25 degrees can be converted to, let's have a look, 27.8 gradients. The third column is just mils, standard mils. So our 25 degrees would be, let's have a look, 444 mils. And the last column is slope percentages. So our 25 degrees is converted to 46.6%. Don't forget from your school days that 45 degrees is 100%. And the reason for that is that percentages on a slope should normally be quoted using the run and ramp. But in navigation, we just tend to say the distance times, plus the degrees. But that's another video. Also on the back of the compass is the screw that you use to set the semi-permanent declination. Now, to find the screw, what you do is turn the bezel until north is underneath the index mark, and then you'll see the screw at the 90-degree indicator on the slope angle indicator on the back. Okay, if you can't see the screw, just keep turning the bezel really slowly and the screw will appear in the little hole. And then all you do is use a small screwdriver to adjust your declination. So that's all the parts of the compass that we're going to use today. Now let's next have a look at how you actually use this compass. And what I'm going to do is, I'm here on the summit of Pike Door at the moment. I don't know if you, that's the summit cairn behind me. So I'm going to leave here and I'm going to go down to this, there's a wall junction sort of in that, let's orient my map. There's the cairn. So there's a wall junction a few hundred meters in that direction. So I'll go down there and we'll have a chat about how to actually use this compass. I've arrived at this wall junction. Now there are three main things that most people want to do with a map and a compass. I know this is a military compass, so there are lots of other things that you can do with it, but my videos are only concerned with people who are going trekking or hill walking. So the first thing that people want to do is they want to be able to take a bearing from a map. If you're going to walk somewhere, then you have to know which direction you're going to go in. The next thing they want to do is, once you've got your bearing, you've set it on your compass, you want to know, how do I actually follow that bearing? And the last thing that people want to be able to do normally is to sight a feature. In other words, they look at something they can see on the ground and they identify it on the map. Now you can use that for working out what things are. You can also use it for doing a resection, which is to find out where you are on the map, get your exact location. So let's go through each one of those things. So the first thing we need to do is we need to be able to take a bearing from a map. So at the moment I'm here at the wall junction and I want to go to Fair Sleets Gate. All I do, place the compass onto the map so the edge of the box is touching where I am and where I want to go to. It doesn't matter which way the map is pointing. Some people prefer to orient their map in a certain direction, so it's pointing north or whatever, but it makes absolutely no difference when you're taking a bearing. So make sure that the edge of the compass is touching where you are and where you want to go to, and then simply rotate the bezel until these two small white lines are pointing straight up the map. So they're pointing northwards up the map, and then you read the bearing from underneath the index mark here. So here I have a bearing of 78. So I've got my bearing of 78 degrees. Now I want to now follow that bearing, but in the majority of the world you're going to have to make an adjustment now for magnetic declination. So I've got 78 degrees, so let's say I had a 10-degree west declination. Because I've gone from a map to the compass, I need to add. So my 78 will become 88. If I had 10 degrees east, my 78 degrees would become 68. So I'd subtract it. But in this area, the declination at the moment is negligible. There isn't any. So the way we do this is we hold the, I'm actually going in that direction down there, but I'm going to face you just so you can see what I'm doing. Hold the compass directly in front of you at about sort of just the lower chest height. This way that you can look along the direction that you're going, and you can also look at something in the distance. So hold it. 78, or whatever your declination says it should be, is directly below the index mark. I then rotate my whole body until the magnetic needle is directly over or in between the two luminous marks. I then look along the bearing. I can't see Fair Sleets Gate at the moment, so I'm going to have to look along, find something that I can see on my bearing and walk to it. and then when I arrive at that point, I do exactly the same, walk to the next point, and you keep doing that. You keep leapfrogging until you arrive at your destination. Don't be tempted to look at something on the horizon and think that that's good enough, because what will happen then is you'll end up walking on a very wide arc, you know. And if you're going out here, if Fair Sleets Gate is here, you could actually walk past it, or at night time just get totally messed up. So always look along, find something that you can actually walk to, not on the horizon, but something in front of you that you can see. Walk to that, and then keep doing that until you arrive at your destination. This is Fair Sleets Gate. How amazing is this? What do you think? Can you see? Don't you think this is just absolutely amazing? Can you see it? You probably think I've gone mad now. As I said, I find it amazing, and I very much doubt that anybody else does. They walk up here and they just go through a gate and that's it. But anyway, Fair Sleets Gate. Well, that's enough of that waffle. Let's get back to the Suunto MB-6. So we've gone through how to take a bearing from a map and also how to follow the bearing. The other thing that most people want to do is they want to be able to look at something that they can see in the distance or on the ground and identify that point on the map. As I said, if you can do that with 2 points, then you can draw those bearings on your map, and where the lines cross, that's your location. But I've done another video on how to do a resection. So let's have a look around. I can't see much. There you go. Behind me in the distance, I'll zoom in while I'm talking. If you look, there's a wall that goes up the other side of the valley. Now the problem is there are lots of walls, and I want to know which specific wall that is. In other words, if I was walking to, you know, would that be the wall I was interested in? So I'll face you, even though it's in that direction, just so you can see what I'm doing. What I do, tilt the compass up until the mirror drops out and it sticks out like this. Okay. I then line up the wall with the 2 luminous markers that are on the top of the compass housing, and rotate the bezel until the magnetic needle is directly between the 2 luminous marks. Let me just do this. Okay. So I've got a bearing of 72 degrees from here to that wall. So we know that we're at Fair Sleets Gate, and we know that we were looking onto the other side of the valley, which is over here, and there's lots of long walls that go up the other side of the valley. We want to identify which one we were looking at. So all you do, put your compass on the map so it's touching Fair Sleets Gate where you are, and then simply rotate the whole compass, keeping it touching Fair Sleets Gate until this small white marker just below the north sign on the inside of the dial is pointing straight up the map. So it'll be there. Okay, so that's that. Now we know the compass now is running along this wall. So the wall that we were looking at 72 degrees from here is that one there. So it's the center wall. Now, don't forget, in some parts of the world, you may have to make adjustments for magnetic declination before you actually start doing all this. If you're taking over a longer distance, you could also use the edge of the draw. So put the edge of the draw on Fair Sleets Gate and then rotate the compass. That way, you know, you get a lot further distance that you can actually use the compass and the map together with. Now, these types of compasses used to be made by a company called Recta, which is a Swiss manufacturer of compasses and optical equipment. They used to call theirs the DP6. Suunto bought Recta, I think, in 1996. Somebody correct me if I'm wrong about that date. And when Suunto took over Recta, they started selling these as the MB-6, which is what we've been using all day. Now, obviously, we can't go back 30 or 40 years to compare and see if this Suunto is actually as good as the original Recta. Or can we? I just happen to have an original Recta DP6 from back in the day, 1985 this one's from. You don't get this from other channels, you know. Now, just looking at them, they actually do, you know, they're to within a millimetre or so, they're the same size. The Suunto, you open it by just pulling on the drawer. With the Recta, you have to press this little button as it's locked, and then you just pull the lanyard. But they do seem to be very similar. The obvious difference, which you'll notice straight away, is that the Suunto, the modern one, uses degrees, whereas the old Recta one, don't forget, that was purely a military compass. So it was the circle is divided into grads, or gons rather, sorry, which is where there's 400 units in a circle, as opposed to degrees where there's 360. You also get, you know, it's the same system where you get the mirror popping out, so you can take sighted bearings. Now, which is better? Some people would disagree with that, I understand it. But in this case, older is not necessarily better. I actually like the new modern Suunto version, the MB-6. Obviously now they have more modern manufacturing techniques, which enables a more accurate compass to be made. Will this one, you know, as I said, this one is from 1985, so will this Suunto still be around in 40 years' time working? We'll have to wait and see. Do you remember right at the beginning of the video? I know, it seems a long time ago. Keep going, we're nearly there. I said that this Suunto MB-6 compass had one of the most amazing ideas for a military compass that you won't see anywhere else. No, it's this. If you look at inside the dial, you can see two pairs of luminous dots, and those are 60 degrees either side of north, or 0. Now, these are used for boxing, which is normally used by the military, but it's a method of walking around an area where you don't want to walk, you know, an obstacle. This could be around a lake or around a steep drop, or anything that you just want to walk around. It's called boxing because the normal way of doing it is to walk in a box shape. So let's say that there's something in front of me that I don't want to walk over, I want to walk around it. I'll turn at 90 degrees and walk out some distance, say 25 paces. I'll then turn at 90 degrees again and keep going on my original bearing until I'm past the obstacle. And then all I do then is I turn back inwards into the box for the same number of paces that I walked out, and then I'm back on my bearing again. That's why it's called boxing. But there is a better way of doing this. Instead of turning at 90 degrees, you should turn at 60 degrees. And that is what the dots are on the inside of the dial. I'll explain. Let's say that you're following a bearing and you come across something that you want to walk around. You don't need to alter your compass. All you need to do is turn yourself either left or right, whichever way you want to go, until the magnetic needle is directly between two of the dots, and then just walk out for a certain distance, keeping the magnetic needle between the dots. So you could go 20 paces or 200 paces or whatever you need to. And then turn yourself again until the magnetic needle is between the other two dots, and then do the same number of paces, 20 or 200, and you'll be back on your original bearing. Now, that sounds quite similar to boxing, you know, it's just a different shape. But that's not what's really amazing about this 60-degree boxing. What you do is, the Swiss military technique is that you're walking around an equilateral triangle, which is where all the angles are 60 degrees. So let's say that you're walking along on your bearing and you're counting your paces like this here, 78, 79, 80, 81, and you see something that you want to walk around. You turn and then put the needle between the two dots and then continue your pacing. So you did, don't forget, you got to 80, 81. So now you turn and you go 82, 83, 84, etc. Once you've got round the obstacle, turn, put the needle between the two dots, and then start that same set of pacing again. So it will be 82, 83, 84. until you get back on your original bearing. Now the beauty of this is, once you're back on your original bearing, say that you walk 20 paces, so you did 82, 83, 84, and you finished back on your bearing, okay? That is the same pacing and the same bearing as if you didn't walk round the obstacle in the first place. So your pacing and your bearing continues from your start point, which may be a few hundred meters down the track. You just carry on. So it reduces any chance of an error in pacing or any chance of an error in direction, because they're actually printed onto the inside of the dial. I mean, all it is 4 luminous dots. How amazing. Honestly, all military compasses should have those dots at 60 degrees either side of north. Anyway, I hope you found this interesting and that you now know everything there is to know about the Suunto MB-6, and also a little bit of waffle about a strange gate in the Yorkshire Dales. But anyway, thanks for watching.